Introduction to the DC motor control trainer kit and the software. So let's see what the hardware kit is about and what are the different components in the kit. You see the various parts are labeled by the numbers 1, 2, 3, 4, 5 up to 18. So we'll discuss about all of these. So number 1 is your Maxon DC motor. This number 1 is the DC motor that is the main focus of the lab. We have to control the speed and position of this motor, and after the motor at number 2 you can see there is a disc. This basically is an inertial load. It is connected to the motor so that when the motor moves, the movement or the position is quite clear by the movement of this load. At number 10 you can see a belt, and this belt is here to create friction for the moving load. So we can connect this belt from this inertial load knob to the knob on the right, and this knob here is for the purpose of supporting this belt. Number 4 is a high resolution optical encoder. Okay, coming at this side there are different ports. First one is the power port. You can connect your adapter, AC voltage adapter here. So this is just like the charging slots, so which means that we will power up our this DC motor control trainer by using the adapter connected right here on number 15. Then there are various then there are various other ports for D2A converter, for tachometer, encoder, etc. and potentiometer if you want to connect them and make the additional circuit here on the breadboard. Okay, then you see here on 6 and 7 we can also download these already programmed algorithms for some procedures, and for that we can connect. This is our RJ1 port, pin number 6. We also call it as jack, and number 7 is the USB connector, which means that we can plug in the USB cable here. So there are two types of kits available in the lab. One of them has a serial connector here, the VGA port, and one of the other type of category has a USB connection here. So it depends upon the software variant which we are using. Both the variants are available in the lab. So if we are using USB, we will connect a USB converter here with the laptop. And if the kit has a serial port connection, then we will be connecting it with another cable for the connection of serial port. Okay, right here on this microcontroller board, it looks like this is the generic board for a microcontroller that we did in microprocessor systems. So this button here is the reset button, and here is your pick microcontroller. And number 3, you see these are the heat sinks, and heat sinks are covering the linear power amplifier, because we have to amplify the voltage that is going to the motor. So what we are going to do is we are protecting this linear power amplifier. 3 labeled here is basically labeled on the heat sink, and it is in the table, it is written as linear power amplifier. So basically these heat sinks are protecting this linear power amplifier. Okay, so this is the table that describes the various parts labeled in the above figure. You can read them again. And this is a schematic view of the same board. So this is actually the reading assignment for you before we begin the experiments. Okay, this table provides the system parameters, and and the calculated values. The manufacturers have provided us these values, and we are going to find out some of these values and compare with them, and we are going to use some values as it is in upcoming experiments. So for the linear power amplifier, the maximum output voltage is 15 volts, the maximum output current is 1.5 amperes, and the power is 22 watt, and that is why the motor is getting the 22 watts and is being operated at that. So the power amplifier has a gain of 3 because from laptop, the USB connection, we are providing 5 volts of the voltage, and that is communicated as 15 to the motor. As I mentioned, the other type of the port looks like this. This would be a serial port connection. In the above figure, there was a USB port right here. Okay, this figure shows how to connect this circuit board with your laptop. I explained a few things before, but let me repeat that this number one is your microprocessor, which is actually going to get commands from the software and communicate them to this hardware board. This is your USB connection, or it could be a serial port connection if the board is different. And this is your AC adapter connection here to light up it, to give it power. This is your inertial load connected to your motor, and this is the user switch button, that is the control for the communication of the code in the laptop to this microprocessor here. So the first step is that we have to ensure that the QIC processor core board, this is the processor core board because it has a microprocessor here, right? So this is properly installed and into its corresponding socket. You do not need to worry about this because we have already connected it the right way here. What you have to ensure is this inertial load. In most of the hardware kits, I have also connected them before the experiment, so a student doesn't have to care for this. And initially this inertial tooth belt should not be connected here because it is going to provide you lots of friction. So it is designed, it is here for specific experiments where we need the motor to be controlled by friction, and we have to study the effect of friction there. So if the connection is fine, then you will see there are LEDs that are going to light up on the board. So these are the two LEDs right with this button here. So if one of them is static on and one of them is going to blink. So you have to plug the AC power transformer into the main supply of your workstation, and then connect and insert the connector into your power jack. So after you first plug in the QIC to your PC for the first time, you must wait for a few seconds until the device is just like you are connecting a USB to your laptop, until it is identified, right? After that, there is going to be an interface where you can select few things. So there will be a 1 to 2 3 step procedure that the PC has recognized a human interface device, etc, etc. The message would be asking you should try to find and install the driver for this, and you have to click yes. This is for the laptops where it is being connected for the first time. But for the lab PCs, the computers in the lab, we do not have to go through all these steps, right? So your today's lab task is to read this first manual word by word, because this is going to help in developing the understanding for the upcoming labs. So you are, after this week's practice of this self-reading assignment, we can call it self-reading assignment because you have to read it out, and block diagram of the schematic and all the pictures of your hardware are here for your help. So today's task is just to read them out and develop a basic understanding and get to know about the various parts of your hardware board. One thing, the hardware and software are necessary together, which means that you cannot run the software without the hardware. So for now, in distant learning mode, you must only read them and develop the understanding of it. I'll be sharing videos for the next experiments shortly. But before that we have to model our DC motor in the next lab. So we will be doing the exercise of modeling our DC motor in the next lab.